Yeah, hi all. Good morning, good evening. I hope everyone is doing good. So today's session, I am going to explain about the custom transformations, right? So last session, I was explain about the optimizing how to optimize the aggregator transformation. So in that transformation, in optimizing part, there is most of the transformation will be participate, right? Last session, I was explain about the aggregator transformations, how aggregator was perform, right? So in this session I was explain like how to aggregator was perform. So that session, right, I was explain in detail, and a similar way I'm going to explain about the today's session in custom transformations, how custom transformation is looks like. Okay, so these transformation is actually how to perform in part of optimizations, right? But yeah, in today I will explain some detail also. If you remember, uh, yeah, here if you remember, I was explain in aggregator there is some performance law. What things need to be noted down. So those things I will explain in detail here in our technical part. Let me show my VDI. Okay, so here I'm just going to take one example of my mapping, and there is some aggregator transformation of what things need to be remembered, right? Yeah, I'm going to take one example who is having the aggregator. So I took only those joiner aggregator, just taking, otherwise I will create new. Okay, just hold on. Union transformations. Yeah, I'm just thinking which one is having. Let me check other one. Sequence. Yeah, here is aggregator transformation. I'm just opening one scenario. Yeah. So the basic thing, what things need to be remember in aggregator transformation? Yeah, here is aggregator transformation, right? So if you notice that aggregator rules was defined, right? The rules was given in slides here. If you remember, rules was given the group by simple column, use sorted input, use incremental aggregation. So yeah, before aggregator, I used here. If you notice, I use the sorter transformation because if you give the sorter input to aggregator transfer, it will be easy to uh, aggregate those data. Okay, so here what they are told, use always, don't use the complex column, right, for your group by. Here is the group by columns, right? uh, let's see, here is the transformation, right? So where how aggregator transformation name, you can, if you want, you can rename as well. Okay, so here is make a reusable, non reusable, you can make accordingly. And second, here is the port, right? Suppose I was taken as a source as employee tables, right? emp name, job number, name, job, my managerial, hire date, salary, commissions, right? Department number. The same, because department number is the number decimal, right? So basically, don't go for your name kind of group by, right? So always just try to, if available, right? Available like a number, then you can try always the number. It will be easy for optimizing those data. Okay. So here, yeah. So let me explain about the complete mapping. Here is the complete mapping, like employee as a source, right? After that, I was used sorter transformation. After that sorter, let me show you the properties. What things here is nothing, just sorter name, and you can just rename if you want. And there is the all port, which one, and here I just emp number I will make as a ascending, right? Here is the multiple option, ascending or descending. So you can choose according to your requirement. Okay, and here option also, if you want to up down, then you can do that way. After that, I used the aggregator transformation, and aggregator same port I transfer all. Yeah, I one things they given, suppose whatever the port is required for your output, right? Those port you can include here. Suppose I don't need write some input, right, commission or something, right? So don't include in aggregator as well, right? So yeah, whatever you require, that one you can include. Otherwise, it will be just took some times, right? That's what here is intention to describe some methods, right? Limit the port connection. Yeah, that's what. So here is all about some detail about the technical. So in today's session, I'm going to explain about the custom transformation. What is the custom transformation in our Informatica, right? So in today's session, yeah, I'm going to give the overview. Overview like the in integration. So our Informatica is all are based on the integration service, right? Because when we trigger anything, right, scheduling any mapping, the integration service is doing everything as it was, right? So integration service can pass a single row to custom transformation procedure or block of row in an array. You can write the procedure code to specify whether the procedure receive one row or block of row, right? So you can increase performance when the procedure receive a block of row. So you can decrease the number of function call the integration service and the procedures make. The integration service calls the input row to notification function fewer times and the procedures call the output notification function fewer times. Okay, so you can increase the locality of memory access space for the data. So you can write the procedure code to perform an algorithm on a block of data instead of each row of data. Okay. So here some thing, yeah. Optimizing joiner transformation. Joiner transformation is nothing. Suppose custom transformation is nothing as the procedure, right? So it next is our joiner transformation. How joiner transformation is doing under the or optimizations, right? Because topic was that. Let me show you. Here is what the topic. What I need to explain you. Uh, yeah. So first is the aggregator I will explain. Now I going to explain the custom transformation. After that, I will explain about the joiner transformation. Okay. Then we'll look up and normalize. So today's session, I try to explain the joiner. After that, in next session, I will try to explain the lookup and normalizer. Okay. So here the joiner transformation is actually can slow performance because they need additional space at runtime. Because when join, because master detail kind of concept, right? So hold intermediary result. You can view joiner performance counter information to determine whether you need to optimize the joiner transformation. Okay. So use the following tips. Here is some tips. What kind of tips, right? Designate the master source as the source, right, with fewer duplicate value q values. When the integration service process a shorter transformation, it caches a row or 100 unique key at a time. If the master source contain many row, right, with the same key value, the integration service must cache more row and the performance can be slow. So what here he just tried to tell us the master row as the source with the fewer duplicate key, well, right? When the integration, because don't include the uh, like that. So second point, designate the master source as the source with fewer rows. Okay, during the session, the joiner transformation compare each row of the detail source and against the master source, the fewer rows in the master, the fewer iteration of the join comparison occurs, which speed the join process. Okay, perform join in the database when possible. Performing a join in a database if faster than performing a join in a session. Okay, the type of database join in the database, such as joining table from a two different tables or flat file. Okay, the to perform a join database, use the following option: create a pre-session stored procedure, okay, to join the table in a database. What it mean, whatever the joining, right, you can just prepone to your database level, so that your performance joining can be happen at a DB level. So use the source qualifier transformation to perform the join. So join transorter data when possible to improve session performance. Okay, configure joiner transformation to use sorted input. When you configure the joiner transformation, right, to use sorted data, the integration service improve performance by minimizing disk input and output. You see the greatest performance improvement when you work with large data set for unsorted joiner transformation. So designate the source with fewer row as the master. Okay. Now the next point is the lookup transformation. What kind of, yeah, for joiner transformation I just show you what things he tell us, going on our technical part. Just taking one example for joiner transformations. Here is one, yeah, union. I'm just checking. Here is one joiner transformation. Okay, I'm just opening a different folder. So yeah, okay. So here is a joiner transformation. So joiner transformation is nothing. If you notice, yeah, here is the employee table and department table I used. After that, I used the two sorter input. Here is sorter. Okay, sorter is required because when you join, it will be easy to put, right. Here is I use the department wise sorting. Okay, so here is the list data. That's what here make the as a master. If you notice here, okay, here is the master as per guideline by Informatica, whatever the column like less record, right? If you know like less record, because a department is the kind of dimension table, right? So that dimension table having the very less record, so we can go with this table as a master. So here also I use the as a port of descending for department wise, and same way here is also department wise, right? Previous employee table. Okay, so after that in joiner transform we place both and make as a detail and a master, right, source type. So here one point you was still suppose if any complex join, right, so that complex join we can put as a here as a source label. After that we can take as a sim wave, right, then you can do. But here is the simple join, so we go with this way. Here I just copy it, right. Here is the configuration normal join, because I need the normal, I need the only particular that department, so I use the normal join. But a join type is like four: normal join, master outer join, detail outer join, right, and full outer join. Total four types of join available with in Informatica. Okay, here is the cache directory. Cache directory you can configure by your own folder as well. So here in null ordering in master, right. So this option also null is lower kind of, if you according to your requirement you can tracing level also for log generation. Here is joiner cache, it's auto, right. Suppose you want to, if you are not going to use this one, right, so you can check here as a sorted input, right. So it will be because joiner or aggregator, right, those these transformation are expecting the sorted input. That's what here is recommending always to use the sorter transformations. Okay, so these are all about your joiner. Here is the conditions. So here is suppose you master column, and here is the operator. Operator is if you yeah, here is one case, right. Always joiner transformation use the equal operator, right. There is no other operator available. That's what we are when you go for aggregator and joiner and lookup and joiner. What is the difference, right? So these are the differences you noted down, right? So here is the all column, which one is your detail table, and here is the master table, right? So you can just take a join and it will be performed accordingly. So these are all about your source, like optimizing our aggregator joiner transformation. And the next topic will take as a lookup. Lookup is very huge kind of, right, there is multiple option tracing cache and right. So we'll take a separate session more, so that I can explain in detail. Yeah, yeah, thanks for watching today channels, today sessions. Yeah, I will explain in more detail. So yeah, thanks for watching.